Okay guys, so I said that I would conduct a video to help you with Workbook 3. I'm going to use the Week 9 homework discussion. So I think there's two documents for Week 9. There's the Week 9 additional homework and the Week 9 homework discussion. The Week 9 homework discussion has been designed specifically to help you with the workbook. Now we're using the same data set as we used for the additional homework exercises in Week 8 and 9, which is the wellbeing1.sav file. We've already looked at the first question, which is basically looking at the 8 items, looking at the correlation matrix and determining that question 1 to 4 all correlate highly with each other but not with questions 5 to 8, and question 5 to 8 correlate highly with each other but not with questions 1 to 4. So therefore we would expect two factors to come out of this analysis. One factor representing a personal development factor, questions 1 to 4, and another factor, questions 5 to 8, representing autonomy, an autonomy factor. So we've already answered those questions. Now question 2a is asking us to produce the factor analysis. So we're using maximum likelihood technique, which is a factor analysis technique as opposed to principal components analysis. We go to dimension reduction, factor, chuck all the variables in there. Under descriptives, ask for univariate descriptors, which just gives you the mean of each item, the initial solution, which gives you the results of the solution, the coefficients gives you the correlation matrix, the reproduced correlation matrix uses the factors to reproduce each item in the analysis and then gives you the correlations between those reproduced items. The KMO and Bartlett's test specificity just tells you how well suited the data is to factor analysis. This wasn't on principal components as a default, so you need to ask for maximum likelihood. Ask for the unrotated factor solution because that gives you all the eigenvalues and stuff. The scree plot plots the eigenvalues for you, so you want that. You just leave all the rest as default. Rotation, we want direct Obermann. Leave the rest as default. We'll ask for factor scores, and we'll sort by size, so that's the sort and blank option. Sort by size sorts the in the solution, it provides the items according to their factor loadings on the factor, so in descending order, and suppress small coefficients, items with factor loadings less than 0.1. We press OK, and we get our solution. Now, that gives us the mean of each item. The items are anchored by a score of 1, strongly disagree, to a score of 6, strongly agree. So you can see the means are all between 1 and 6, and generally hovering around 2 to 4, or 3. This is the correlations between the items. Most of the items will correlate. You want all items to correlate at least 0.3 with one other item, which they do. KMO and Bartlett's test specificity, you want the Kaiser-Meyer-Olkin or KMO value to be greater than 0.7, and you want Bartlett's test to be significant, and that just shows that the items are suited to factor analysis. Don't worry about the communalities, but one thing you need to be aware of is that with a factor analysis technique such as maximum likelihood or principal access factoring, the initial, it doesn't use all of the variance in each item for the solution, it just uses some. So the initial communalities are not 1 like they are with principal components. And then that's the amount of the extraction is the communality, that's the amount of variance in each item that's explained by the factor analysis. They're all of the factors together. So here you can see there's only 2 factors with eigenvalues greater than 1, and one explains 38%, the second explains 18% of the variance in the items, and that's just these eigenvalues. The scree plot is just those eigenvalues plotted. So the scree test is basically you reject any items below the elbow. You can see there's a clear elbow. So these factors would be rejected, and you retain these factors. So ignore the factor matrix output and go down to the pattern matrix. This is the reproduced correlation matrix. So using the factors to reproduce the items and then taking the correlations between those reproduced items, you get these reproduced correlation matrix. The goodness of fit test tells you how well the reproduced correlation matrix fits with the original correlation matrix. You don't want this to be significant because this tests how similar they are, and you want them to be similar. So if it's significant, it shows that they're significantly different, which you don't want. So you want this test to not be significant, which it isn't, which is good. And then the residuals tells you the difference between these predicted values that are using the reproduced items and the initial correlation matrix with the correlations the original correlations between the items. So this tells you the difference between the original correlations and the reproduced correlations. And you want these, or you want most of them to be less than 0.05 and none of them to be greater than 0.1. So you can go through, you can see one there is greater than 0.05. There's another one here that's greater than 0.05. So 2 greater than 0.05 is okay, but we've got one down here that's greater than 0.1, which is no good, so we want to try and fix that. So the factor solution is looking pretty good so far, except for that one residual greater than 0.1, which is no good. So just see which item that's on. Oops. So that's the correlation between item 8 and item 5. So the correlation between item 8 and item 5 is producing a residual greater than 0.1. And there's also some residuals greater than 0.05 on item 1 as well. So okay, and so the pattern matrix is the factor loadings that you want to look at. So you can see it's really clear. Item 5 to 8 load on one factor, and items 1 to 4 load on another factor, and that's good. That's what you want. You want it to be, that shows simple structure. So far everything's really good about the analysis except for the reproduced correlation matrix. So question 2a, that was has the SPSS factor, so question 2a was telling you to run the analysis, and question 2b has the SPSS factor procedure identified the factors you expected. Yes, the pattern matrix shows that it has. Question 3, is this a good factor solution? Discuss how well the factor solutions meet each of the criteria listed on page 271 of the text. Actually, there is nothing on 271, it's on page 254. Okay, so that's basically the first one. I'll go to page 254. Page 254. So it starts by saying the residuals in the reproduced correlation matrix. Most of them should be less than 0.05 and some are greater than 0.1. So you shouldn't have any greater than 0.1. We had one greater than 0.1, which isn't great. So that wasn't too good. The factors should explain a reasonable percentage of the variance, generally greater than 50% in the social sciences. So you can see ours was greater than 50%. Altogether, our factors explained 57 or something, I think it was. 57%, so that's okay. The factor solution should show simple structure. It doesn't have to be perfect, but variables you want to have loading. I say loading less than 0.3 on other factors. Here it says loading less than 0.5. All variables. All variables should have a substantial loading with at least one factor. Say a loading of 0.5 or more. Generally, you want loadings of 0.5 or more. Which our variables show really good loadings. If we go down to the pattern matrix, they load more than 0.5 on factor 1 and more than 0.5 on factor 2, so we've done that, that's fine. So I clicked onto the wrong thing. And if we go down again, factors should have significant loadings with more than 2 variables. So we've got that, we've got 4 items on each factor, so that's fine. So you want more than 2 items on each factor is basically what that one's saying. Most importantly, you must be able to interpret the factors meaningfully, which we know we can do because one represents an autonomy factor, the 4 items represent an autonomy factor, and the other represents a personal development factor. So far so good. Our analysis is looking good so far, except for the residuals which we want to fix. So question 4, try to improve on this factor solution. Report what you tried and why and whether you thought it was an improvement or not. So basically what we will probably do is rerun the analysis and try excluding question 8 because question 8 was the one with the high residual. So we'll go down to dimension reduction, we'll get rid of question 8 and we'll try again. So you only want to, when you rerun an analysis, you only want to exclude one variable at a time, never exclude more than one variable. So let's go straight down to the reproduced correlations and have a look at the residuals. So now we've got residuals that all we've got one greater than 0.05, which is fine. The rest look really good, so that's great. Let's have a look at our goodness of fit. It's not significant, which is good. Our pattern matrix is still really clear. We've got 3 items on factor 1, 4 items on factor 2. There's no cross loadings between the items. Let's make sure we still have more than 50% of, now we explained 61% of the variance. So now the factors solution's looking really good. We've got no issues. So let's just have a look at the answer to that question. So we've said that the question 3, which we already looked at before, is basically saying it's a reasonably good factor solution, but the residuals aren't great. Going down to question 4, where we just repeated it, it says you might reduce, in order to reduce the number of residuals greater than 0.05, we could try introducing a third factor, or we could try removing problem variables. Looking at the eigenvalues, we can see a big drop from factor 2 to factor 3. So factor 3, the eigenvalue was 0.61, which is too low to consider including 3 factors in the solution. So instead, we could try removing question 8 or 1 from the solution, because they're the ones that are producing the large residuals when comparing the initial and the observed and predicted correlation matrix. So we removed question 8. So removing question 8, it's also been done in the solutions, which is good. So removing question 8 looks good. There's only 1 residual greater than 0.05. It explains more variance, 60%. That still displays simple structure. Each factor is still defined by more than 2 variables. The factors are still meaningful. So it is probably an improvement on the original solution. Okay. So question 5, once you've agreed on a final factor solution, describe the sort of person who would score high on factor 1. Describe the sort of person who would score high on factor 2. Give a possible name for each of the factors and describe the correlations between factors 1 and 2. So for the first factor, we had items 5, 6 and 7. So the items are quoted from strongly disagree to strongly agree. What items have substantial loadings on factor 1? So these are the items. Items 5 to 7 are not afraid to voice opinions. I'm not afraid to voice my opinions. I don't give in to social pressures, and I do change to fit with others. So these are basically, the first 2 are positively worded, and the third one's negatively worded. So are the loadings positive or negative? So I'm not afraid to voice opinions, and I don't give in to social pressures. They both have positive loadings on the factor. So if you were to graph that, so you want to have a positive line, so it's a low score for strongly disagree and a high score for strongly agree. So people who strongly agree that they are not afraid to voice their opinions, and who strongly agree that they don't give in to social pressures, tend to score high on factor 1. And then I do change to fit with others. This has a negative, the loading on, I'll show you what I mean by that. So when you go down to the pattern matrix, you can see questions 6 and 7 have positive loadings. Change to fit with others has a negative loading on factor 1. So that means you need to draw a negative line. So those who score high on the item tend to disagree, and those who score low on the item tend to agree. So people who strongly disagree that they change to fit in with others tend to score high on factor 1. So the sort of person who would score highest on factor 1 is someone who is very independent, who tends not to be swayed by others. So they strongly disagree with the idea that they change to fit with others. So that's someone high in autonomy. So for factor 2, what sort of person would score high on factor 2? We've basically got the items gave up on big improvements, which is negatively worded, and not interested in expanding horizons. So they have positive loadings, and enjoy new situations and new experiences are important. Have negative loadings. So over here, you can see enjoy new situations and new experiences is negatively loaded. The other 2 are positively loaded. So basically, if you gave up on big improvements, that the loading is positive. So if you strongly agree that you give up on big improvements, you will score high. So people who strongly agree that they gave up on big improvements in their life will tend to score high on factor 1. And then the other items are negatively worded. The other items are negatively scored. They negatively load on factor 2. So those who score high on enjoying new situations, I enjoy new situations, tend to disagree with the item I enjoy new situations. So the sort of person who would score highest on factor 2 is someone who strongly disagrees that they enjoy new situations and that new experiences are important, but strongly agrees that they have given up trying to make big improvements in their lives and they're not interested in expanding their horizons. That is, someone who is not at all interested in personal development would score high on factor 1. So the items will probably be negatively correlated, because people who are autonomous score high on factor 1, but people who tend to not be into personal development score high on factor 2. Okay, that word there, that should be 2, would score high on factor 2. So give a possible name for each of these factors. So we'll call factor 1 autonomy and factor 2 interest in personal development. And then question D, describe the correlations. So we'll have a look at the correlations between the items. Did we request that? I think we did. Down here you've got the factor correlation matrix. So that's the correlation between the factors, and you can see they are negatively correlated as I predicted. So we've got, if we had factor 1 on the bottom here, we've got low autonomy is a low score and high autonomy is a high score. Factor 2 is the vertical axis, so high interest in personal development. People who are highly interested in personal development scored low. People who were not very interested in personal development scored high. So there's a negative correlation. There is a weak linear relationship between autonomy and interest in personal development. There's a slight tendency for people with more interest in personal development to have more autonomy. Because interest in personal development is a negative item, where those who score high tend to have less interest in personal development, but they're negatively correlated. So it ends up being that those who are more interested in personal development tend to have higher autonomy, and those who are less interested in personal development tend to have a lower autonomy. Okay. And that's all of the questions discussed.